relative power of the mother within the household. But the reason I'm telling you this is that all of these measures, you know, this costs money. Okay, when I do a survey in a developing country, I mean, I think I've been associated or set up like 20 different surveys in different countries around the globe, mainly in sub-Saharan Africa, sub-Saharan and North Africa, but not just there, in Brazil and Haiti, the Philippines. These are expensive data gathering exercises, right? Depending upon the country you're working in, let me just take one out of the blue. Morocco, one household, everything included, is going to cost you the equivalent of like $30, roughly $35. That's the cost of collecting data on one household. Okay, so $30, you multiply that by 2,000 households, you can do the math better than I can do. So this is going to cost significant money, right? And when I do an impact evaluation or work on a survey, my question, I try to measure things in terms of a metric: is it worth it, right? Is it worth it, apart from, you know, the intellectual stimulation of collecting data and understanding how the world works? Should the government put it in something else, right? My favorite metric is schools. Okay, and schools cost a different amount of, like in sub-Saharan Africa, a school costs about $15,000 if you want a hard floor and chairs, okay, and chairs and desks. So if you spend, you know, $150,000 on a survey in Senegal or Burkina, are you going to get a payoff from that, right? Which is worth 10 schools not being built. But I think as social scientists, we should be thinking about this. And what I'd like to just speak to you briefly about today, I have like half an hour or something like that, 45 minutes, yeah, half an hour. I don't want to bore you too long. Is a type of data that a lot of you are familiar with, and which sort of entered the development economics space literally 12 years ago, and that's remote sensing data. There are various kinds of remote sensing data, and what I'd like to give you is 3 examples, essentially, of the use of remote sensing data, in particular of NTL, of nighttime luminosity, okay? And its use in development economics research. Okay? And the key thing about NTL is that it's free. Okay? You can go on the NASA website and you can download this stuff. Now you have to have a hard drive or have a bit of space in the cloud to be able to do this, and you have to know what you're doing. But there's tutorials online. You know, the NASA site is fabulous. You write to NASA, they answer. Okay? There are not very many institutions which will actually answer you. I mean, I've had Chinese PhD students who back to China, a Chinese email address, NASA answers. Okay, so these are real scientists, and that's kind of refreshing. And the thing is, another way I'd like to put this is, you can't write a good paper today in economics, or you can't evaluate anything. It's writing good papers or evaluating some kind of intervention, whether it's in the public sector or in the private sector. It's almost impossible today to do something which is really good if you don't combine several sources of data. Okay, so even if you've got a national sample survey, you know, household data, or the ICRISAT data, you know, from the 5 ICRISAT villages, you know, you're never going to do something really interesting if you don't cross that with something else. And we have this wonderful tool today, which is, you know, georeferenced data. And the fact that we have these georeferenced data, we have precipitation, we've got temperature, we have, you know, topography, and all this stuff is free, right? All of this stuff is free. And if you want to, for the students in the room, if you want to write interesting papers, and for the people who are in the private sector in the room, if you want to actually try to figure out what's going on with your activities, you have to combine these different sources of data. So let me give you 3 examples, actually a small prolegomena, and that is the type of data. Whoops, come on. Nope, he's not collaborating. Okay, just a minute. There we go. This is a typical picture. This was for friends in Tunisia. So this was the old data, okay, which had really poor resolution. So this, in the middle of this, is actually the Tunisian revolution. And it's like in 3 years you see nothing in terms of evolution. But over the long run, with the black marble data, so just remember this name, black marble. Okay, so black marble, those are the modern data out of which has the best resolution. This is Tunisia over a 10-year period, and here you have very nice resolution, and you can see that stuff is changing. Okay, and these are urban areas, and you can see that the light has become much greater in urban areas as these urban areas grow. And you can basically have proxies for aggregate behavior. This is like total NTL in Tunisia over time. You can do this for India. You can do it for Indian states. here's a nice picture. This is Delhi with the old, this is, so, whoops, these two different types of satellites, they basically, they join in 2012. This is the old resolution. You can see it's pretty bad. And this is the new resolution. So just in terms of time series, we have data, the high resolution black marble stuff, starting in 2012. Okay? So, and I wouldn't start before because it's very difficult to splice the two things together, but starting in 2012, we have lots of information. And you know, these are really good data in terms of correcting. I mean, all the algorithms that they use to correct the data, really nice. Now, for the non-geeks in the room, forget this, okay? But for the geeks in the room, the basic introduction of NTL into the economics literature was this paper in the AER by Henderson, Storygard, and Vail in 2012. That's why I say it's been a dozen years. Okay, that's the paper you want to read. And basically what they showed is that there was very strong correlation between economic growth and growth of NTL. Okay? And what it provides you is in places where you don't have disaggregated measures, such as in sub-Saharan Africa, you can actually follow, or in rural areas in India, right? You can actually follow what's going on by following NTL. And again, sort of in statistical parlance, the R squared that you typically get when you take small units, you know, I mean, I'm talking about really small units, so like village units, the R squared of, you know, between NTL and income measures is like 0.8, okay? So 80% of the variation in income is explained, is associated with, you know, with NTL. And it isn't just electrification, okay? This works also in places where there isn't any electricity. I use this all the time in places in Africa where there are no electricity grids because NTL shows up in terms of gas, you know, lighting, campfires, people who work on pastoralists. You can use NTL for the campfire. Anyway, I mean, this is the sort of the uses are infinite. And I put I'll leave this stuff here. There's a whole bunch of things. Python to link the black marble data to Google Earth, you name it, and then there's some just pretty pictures. This is aesthetically very pleasing. Okay. This is 2 years in Morocco. So the reason I'm just showing you Morocco here is when you look at this picture, you don't get the impression that there's any change, right, between 2012 and 2016. It just looks like two pictures, you know, where you see Casablanca, you see Rabat, right? You see Marrakesh here. So you say, okay, what has changed? It turns out when your unit of observation is the pixel, okay, and you have a measure of income or expenditures or something like that, or it could be access to finance, okay? It could be something like that. There's a very strong correlation at the pixel level. So when you actually then do a regression of income on or expenditures or something like that on NTL, the correlation is very high. Okay, so you don't see it with the naked eye, but actually it's there. Okay, and it's very strong. And I'll give you various examples. This, for example, is quarterly data. This is macro data. Okay, so NTL works for macro data, time series. The blue thing is NTL. The red dots, that's log GDP of Morocco. So it's basically total NTL in Morocco, the saturation of light, and you see it tracks GDP really well. And contrary to GDP, you can do this for all the delegations in Morocco, so all the units. So if you want to track economic activity in the 1,000 geographical units in Morocco, you can't do that with GDP, right? Because they have some numbers at the governorate level, but there's like 8 governorates. Okay? But you can disaggregate this to 1,000 different geographical units, the smallest geographical units, using NTL. And you know roughly from the macro data what the exchange rate is. Okay, I say exchange rate in inverted commas between NTL and income. But it could be something else as well, right? And there's a lot of stuff that could be explored. This also works in the cross section. Okay, so I showed you time series. So a lot of people in the room, the geeks in the room, will be aware of the stuff by Daron Acemoglu, Johnson Robinson, so all this stuff basically on the sources of economic growth. That's why I'm taking former colonies here. It's taking the AJR. For those of you who are not academics, don't worry, but it's just that this is a standard data set that people use in cross-country growth regressions, okay? And what you're seeing here is on the horizontal axis, it's purchasing power parity log GDP per capita, axis, it's luminosity per capita in the same year. And as you can see, the relationship is really strong. So whether you're looking within a country or even within granular, at a granular level within a country, over time it works. And it also works in the world, right? This correlation is really, really, really strong. It works better for some countries, works less well for other countries. In fact, there's a cheeky paper, it's an NBER working paper, where one of the variables that they put in to explain the link between NTL and GDP, one of the key variables which explains the difference between the two is autocratic governments. Okay, so it's sort of meaning that autocratic governments essentially massage the GDP data, right? But you can run, but you can't hide from NTL, right? Because that's the satellite it's seeing you. So you can lie about the actual GDP data, but you can't lie about NTL. And it explains, it's one of the variables which explains the gap. When it doesn't work, it's the GDP data, it's not the NTL data. Okay, so from the econometric standpoint, what I want to show you is simply that, it's a great outcome indicator. It's compatible with any identification strategy. So I mean, whether you're doing, sort of an RCT, God help us, or you're doing regression discontinuity design, or whether you, whatever type of econometric technique, it's just another type of data. Okay? It's nothing more, nothing less. Okay? It has the advantages and disadvantages. It's nothing new, right? It's just another type of data, and you can combine it with all sorts of other types of data. And I'm going to show you 3 examples, okay, of the use of NTL. Okay, the first one is in impact evaluation. This is impact evaluation for a massive program in Morocco that I was responsible for evaluating, which was called the INDH, which in French is the Initiative Nationale de Développement Humain, the National Human Development Initiative. First phase was $1 billion. Second phase was $2 billion. Third phase was $4 billion. Okay? Now I know for India that's change. Okay, it's change that someone keeps in their pocket, right? But Morocco is a fairly big country, and that's a lot of money. Okay, when you're talking 4 billion over a 4-year period, like $1 billion being injected, Morocco is 30 million people, right? So it's a fairly big country. It's half a typical Indian state, but it's still a fairly big country by international standards. And the way, this is just to illustrate how you can do this. So this is RDD, regression discontinuity design, okay, which is like credit scoring, right? Works with, I don't have to tell people in this room, works, you can do RDD on credit scoring, right? The people who are just above, the people who are just below, the people who get it are just above, the people who are just below it who don't get it, right? This is sort of standard. Economists rediscovered RDD, by the way, in 1999, a famous paper by Angrist and Lavie. Political scientists have been using this since the 60s, okay? Because democracy works in a way where there's a discontinuity at 50%, right? You get 50% plus 1, except if you're called Donald Trump. But if you get 50% plus 1, I'm Canadian, I'm not American, okay, so I can say that. It's a standard discontinuity. Okay, so this was a program, and many bureaucratic things in the world, whether they be in the government sector or in the private sector, bureaucrats and administrators, again, private or public, they have rules to determine what they do. Now the rules can be smart or they can be stupid, that's besides the point. As economists, we can exploit those rules to say something rigorous about impact. Again, even if you're not an economist in this room, anyone in this room who's not an economist, you understand that when you do an impact evaluation, when you want to try to attribute something to something else, to some treatment, you need to have a counterfactual, right? You need to have a twin. You have to construct a twin, right? I show my age. It's like there's a famous Star Trek episode when Captain Kirk and Spock were still part of the series, where the world is turned on its head, right? And so the Federation are nasty, the Klingons are good, the Vulcans are illogical, right? So then the question is, it's a parallel universe. That's what you're trying to do when you do an impact evaluation, and RDD allows you to do this. So this was a program deployed by the Moroccan government, big program. The king was behind this. It's sort of like he calls it his chantier de règne, which means it's sort of it's the big enchilada of his whole reign. Okay, the king is quite ill in Morocco, so he won't be of this world for very much longer. But the way they decided to deploy it, and you can agree or disagree, but that's not the point, is any rural commune. So in India it would sort of be, it's sort of the panchayat level, Gram panchayat level. Okay, so like it's a group of roughly 40 villages in Morocco. Okay, any rural commune which, according to the poverty map, of 2004, and they were starting to disperse in 2006. Any place which, according to the poverty map from 2 years before they started dispersing, any place that had a poverty rate, so the proportion of households who had a household level of household expenditures which was below the poverty line, okay, which is a national poverty line. Every country has national poverty lines. Okay, those places got the program. Okay, so if you were living in a place, if you were living in a rural community which had a poverty rate of 30.01%, you got the program. If you were living in a place which had a poverty rate of 29.99%, you did not get the program. Okay, so even if you're not an economist, you can see very well that the difference between a rural community with a poverty rate of 30.01 and a rural community with a poverty rate of 29.99, they're basically twins. Okay, so that's why it's called regression discontinuity, because what's known as your treatment status, the fact that you get the program, it changes discontinuously at that threshold of 30%. Okay, so this is a program that we evaluated. We evaluated using conventional household surveys, cost a truckload of money. But I wrote a little paper for His Majesty the King, which was called the INDH, the National Human Development Initiative, from outer space. And I said, Your Majesty, you can see the effect of your program from space. So what we have here, so this is from the actual report, so it's written in French. Okay, that's why it says variable de forcing. Okay, so the forcing variable. So that's on the horizontal axis, you have the poverty rate in a rural community, okay, in 2004. Okay, centered on 30, on the threshold of 30%. Okay, so when it says 0 here, that means you're in a rural community which has a poverty rate of 30%. When it says 10, it means you have a poverty rate of 40%. When it says minus 10, you have a poverty rate of 20%. Okay? What we have on the vertical axis is luminosity. It's average nighttime luminosity in that rural community. Okay, in that group of 40 villages. Okay? In a given year. Okay, this is over several years. Okay? And so what do you expect? You expect to see a downward sloping relationship. Okay, this is estimated non-parametrically. Okay, so technically speaking, this is what's known as a local linear regression to the left and to the right of the discontinuity. Okay, so it's basically non-parametric. You just do a smooth. You expect it to be downward sloping, right? Because the higher the poverty rate must mean that the lower the level of economic activity, right? So the higher the poverty rate, then the lower the amount of NTL. That's what you see. You see it's a downward slope. But what you also see, if you look very carefully, is here at the discontinuity, the curve jumps up. Okay? It jumps up, and the amount of, it's a little bit more complicated, but I'm not going to get into sort of the geeky stuff of how you estimate the standard errors and everything and the clustering you've got to do. But basically what we were able to show, and this costs 0. Okay, I wrote the thing in 2 days. Okay? Cost 0, wrote it in 2 days. We showed that the program was increasing NTL in rural Morocco by almost 20%. Okay? And you would not have had to do an expensive survey. You could do this free. Okay? What I've been able to show is that actually the effects of the program have disappeared over time, which happens quite often, right? So if I wanted to do that with household surveys, I'd have to spend $400,000 doing another household survey, which seems like kind of a lot of money to spend to prove that something isn't working anymore. Okay? Whereas I can do it with NTL for free. Okay? And there's all sorts of possibilities. The private sector should be using this to evaluate all sorts of things that it does. Okay, so that's first example. So it's impact evaluation, you know, with a perfectly kosher identification strategy, RDD. I mean, you know, even the JPAL people will not sneeze too much on RDD. They don't do it, but they won't sneeze too much. Other example. Okay, so big picture stuff. This is just to show you, this is because there's some really pretty pictures. Okay? There's all sorts of weird data out there that people make. So the people in geographers, okay, so this is a bunch of crazy Dutch, okay, who've basically constructed land use for the world at 0.08 degree resolution, going back to 10,000 BC. Okay, using sort of all the archaeological literature. You can criticize this stuff, okay? Some of this is very much, it isn't Vermeer, it's Cézanne, you know, it's sort of very broad brush strokes. Again, here you get all sorts of interesting things. So why am I talking about this? The reason I'm talking about this is that there's one of the most important papers written in the past 25 years, which explains an awful lot about the development process, is what's known as the reversal of fortune. And this is why Daron Acemoglu someday will get a Nobel Prize. So what Daron, who's at MIT, but he's not a randomista, he's not a JPAL guy. What Daron has shown, basically, and this is why this paper, it's a beautiful paper. It basically shows the places that were poor 500 years ago, on average, are rich today, and vice versa. Okay? So that's why he calls it reversal of fortune. It's a wonderful story, right? So places that were rich, really rich 500 years ago today. So, you know, the empires in Latin America, India, various kingdoms in Africa, okay? They're relatively poor today, relatively poor. And the places that were really poor 500 years ago, like South Africa, by African standards, was really poor 500 years ago. North America, okay? Other parts of Latin America, okay? They're rich today, right? And by the way, so this isn't coming from colonialism. That's why it's a sample of ex-colonies, because my native, not my native land, my passport land, Canada, is an ex-colony. The US is an ex-colony. South Africa is an ex-colony. New Zealand is an ex-colony. Australia is an ex-colony. Okay, so the reason for restricting it to ex-colonies is simply because you want to get the colonial issue out of the way. So, you know, European countries here, the colonizers are not included in the sample, not because there's nothing interesting to say about them, but it's sort of to remove the issue of colonialism here, okay, just as sort of ceteris paribus. But this is an example of where, so he gets this result, which is basically a negative coefficient. So you have a measure of land use, of population density, 500 years ago. That's a good measure of economic activity, and that's the key right-hand side variable, where on the left-hand side you put GDP per capita, okay? So you have at most 100 countries where you can do this. Okay? Here, I have 1.2 million observations because it's pixels for planet Earth, okay? And I have a measure of population density in 1500 coming from these crazy Dutch guys who could, so it's full of mistakes, okay, these data. And if you start looking at it really carefully, you can criticize it. But the point is, the reversal of fortune only happens in certain places. So here, the stuff which is blue means it's a positive coefficient, the stuff which is red, it's a negative coefficient, okay? So it turns out when you start looking at stuff at more granular level, okay, it turns out that the reversal of fortune, sometimes the reversal is reversed. Okay, and it really depends probably about the political institutions which are in place. I'm not going to dwell on this. Here's a really pretty picture. Okay, this is a really, really pretty picture. So here you have population density, because this is stuff where we can actually be fairly happy about the data. So here it's population density, US and Mexico, nighttime luminosity, US and Mexico, and then looking at how this interacts with slavery. Okay, because Mexico, just like with the U.S., in the U.S. there's the Mason-Dixon line. In Mexico there were slave states and non-slave states. It was partly coterminous with silver mines. But anyway, this is the sort of thing also where we can look at the relationship between population density 500 years ago, or 550 years ago almost, and nighttime luminosity. And we can do that at a disaggregated level. We can't do that for more. If we were doing the U.S. and Mexico, it'd be 2 observations, right? So you can't do it with 2 observations. Right? But here we have 33,000 observations at the pixel level. Okay, so that's just another example. You can do really interesting stuff using NTL. Finally, let me show you how you can do this. You want to do something quick and dirty. Okay, when I say quick and dirty, so this is a paper that I wrote. So one of my 70 kids is a guy called Rami Alaze, who's a Palestinian who works for the UNCTAD, for the Palestine unit at UNCTAD, the United Nations Conference on Trade and Development. Okay, so they deal with trade issues, but they're also the people who maintain the LDC, right? The LDC's least developed countries, et cetera. It's one of the standard organizations in Geneva. And so one of the things that we were interested in doing was figuring out what the economic costs of the war in Gaza were. Okay, so you can go to the website. This is a paper that we wrote in 2 days. Okay, it took us 2 days to write this. So I'll show you some more recent stuff up until, I think, up until May. We have stuff all the way up until the end of September. So what you have here, so what do we do here? We combine 3 sources of data. Bombing maps, okay, and this is what we were talking about earlier. So the 10 by 10, they prefer to aggregate up by 40 by 40, but it's bombing maps, which basically, the grids are 10 by 10 meters. Here it's aggregated up to 40 by 40 meters, then we're going to aggregate it up to 1 kilometer by 1 kilometer. This is for technical reasons because there's a lot of spatial correlation. There's a lot of papers using spatial data where you get spurious correlation. Sorry for the non-techies in the room, but for geeks, be careful, beware of spatial correlation. You can get spurious correlation and say that something is statistically significant when actually it isn't. Okay, so spatial correlation is something important. So these are bombing maps for where each red point here is one of these 40 by 40 meter pixels that was hit by planes or by artillery. Okay, and so this here is from the beginning, 7th October to 22nd November. That's 23rd November to 29th November. That's the ceasefire, the first ceasefire. And then this is the total damage that's up until May. I have more recent things yeah, it changes obviously, but anyway. So that's treatment, okay, in impact evaluation parlance, okay? And we follow this day by day. And so these are friends at Oregon State and the City University of New York who constructed these data, which are freely available. You go to www.conflictdamage.org. Okay, all of this stuff is open source, available to anybody. This is in detail, like this is Gaza City. So you see the intensity of bombing. Okay, each of those little things, that's basically, that place has been bombed. If when you aggregate, and I'll show you in a second, when you aggregate up to the 1 by 1 kilometer, starting from the 40 by 40, so how many pixels are there? You can do the math. There's 625 of them. There's certain 40 by 40, sorry, 1 kilometer by 1 kilometer pixels where 623 out of the 625 have been hit. Okay, so there's basically nothing left in that 1 by 1 kilometer. Okay, so that's going to be treatment, and we follow this over time. Okay. So this is aggregating the thing up. It's the same map as before, but aggregated up to the 1 kilometer by 1 kilometer. Okay, because we don't want to have our results driven by spatial correlation. The next picture, this is NTL for Gaza. Okay, so this is NTL for Gaza. So this is between the 22nd of September and the 6th of October. So that's the week before the Hamas people crossed over the border and massacred all these people in southern Israel. Okay, then we have the 23rd of November. 30th November, last night of the ceasefire, and then this is the night of 21st to 22nd May. Okay, so this is all aggregated up to the 1 by 1 kilometer. The only complication you have when you're doing NTL and merging it with other stuff is you sometimes have to resample so that it's the same grid overlay. But that's trivial to do. Believe me, you can learn how to do this very easily, and there are lots of tutorials which tell you how to do it. And so then what do we do? Well, then this is in econometric parlance. This is a diff-diff. This is a difference in differences. Okay? So it's difference, it's the new, again, for the geeks in the room, so there's the special issue of the Journal of Econometrics from 2022, the summer of 2022. So it's staggered differences, referees like this in journals. But the point is, this is policy stuff, right? What we want to do is we want to get an estimate on NTL, the impact on NTL of the bombing. And then, what do we want to do? Then we have the exchange rate, because I've been working on this stuff for a long time with colleagues at the UN. So I have the exchange rate. So between NTL in Gaza and the West Bank, I have the exchange rate between NTL and household incomes. Okay, because I've estimated that. It's a number, right? The number can be refined. You can do it, you can have a number which is specific for a given geographical region, but these are the impacts, okay? So this is the cumulative impact. So if you look at the cumulative impact, okay, and of course you run regressions, right, to make sure that you're not picking up something, right, because the treatment starts on, right, this is on October 6th, right? So after that, there's treatment, the bombing starts. All this time before in September, October, okay, as you can see, it's centered on 0. Okay, so there's no statistically significant effect. Those are 95% confidence intervals. Okay, 0 is contained, as you can see within, sometimes it's above, sometimes it's below. And then once the actual bombing, so this, I won't get into the econometrics behind this, but basically what you have, depending upon the estimation that you use, you basically have, getting to 20th of May, the numbers have gone up in the meantime. We can very simply, this is trivial, this is stuff that I used to have my kids in my master's class in impact evaluation and econometrics estimate. Okay, so you don't need to be, Jerry Hausman or Jim Heckman, to be able to do this. Anyone with a master's degree or who is doing a master's degree can do this kind of estimation. And this is all done in R. Okay, all of this is done in R. So you have a fall caused by the bombing of between 42 and 45%. Okay, and then the last step is we have basically all of the Palestinian data from PCBS. We have all of the data. This is the correlation between Gaza GDP, and nighttime luminosity. The macro elasticity is 1.22. That's a 1% change in nighttime luminosity leads, sorry, a 1% change in nighttime luminosity leads to a 1.22 change in GDP. We get roughly the same number if we use household surveys. Okay, so we use household surveys, we do poverty mapping, so we combine household surveys with census data, and then we basically get a noisy measure of the expenditures per adult equivalent of every single household in the Palestinian territories. Then we group them up to sort of the municipal level, basically, to the sort of large village level, and then we correlate that with nighttime luminosity, and we get an exchange rate of like 1.13. Okay, so whether we do macro data or we use micro data, we get basically the same number. And so then what we can do is we can change, we can convert. And what's nice about this, I mean, it's a tragedy, obviously, on both sides of the border. But what we can do is we basically, for each of the 22 municipalities in Gaza, we can estimate, given that we've estimated the fall in nighttime luminosity, okay? Those are the numbers that I gave you before, those are the average effects, right? But of course, the effects are not the same everywhere, right? So the Gaza City and northern Gaza have been pretty much obliterated. That's up there. And so you can see that actually the effect of bombing on the household expenditures per adult equivalent, these are large households, so you have to do it per adult equivalent, are basically, goes up to 60%. And that's in May, and it's gone up even more in the meantime. Okay? So this is just to show, again, it took us 2 days to write this. 2 days, okay? Because we just downloaded the data, we got the data from our friends on the bombing data, we already had the stuff, and India has, for example, all these data, right? I mean, I'm not talking about the bombing data, obviously, but what I'm saying is that it's very easy to combine NTL data with existing micro data, and then it's up to you how you then use this to do any kind of impact evaluation. So NTL is one of many types of remote sensing. Okay, so for example, I used to work a lot in China. So one of the things that I worked on with a bunch of colleagues in China were ghost cities. Okay, and so we were using NTL, and we'd find these places, and the Chinese build these huge cities, 8-lane highways. They're illuminated like crazy at night, and there's no one living there. Okay, so NTL isn't perfect. Okay, that's a caveat. So then what we had to do in China is we had to cross that with WeChat traffic. And we realized that once we crossed the NTL with WeChat is the WhatsApp and the Chinese version of WhatsApp, works a lot better than WhatsApp actually, but then we were able to disentangle the two. Okay, so it's not a panacea, okay? You have to be careful on certain topics in certain places in the world, but there's all sorts of remote sensing data out there which can be internet traffic, telephone traffic, then you have to, we've used this in Africa, and we try to, when we do research on this, we try to get, involved with the local Orange and people like that in West Africa. But there's all sorts of information remote sensing there. I'll leave this so the geeks in the room can go and look at the various sources of remote sensing. And I would be remiss if I say that this is not my work, work of a whole bunch of people. Pinyi Chen, very good Chinese PhD student of mine, Rami Abdelmouti, Alazze, who's at UNCTAD. These are all people who, apart from the last guy who's in Morocco. So Daniele Rinaldo is a professor at Exeter. He'll get tenure this year. He's out of the 70, he's the best. He's number one. He just has, as my wife says in French, she says, il a une case en plus. He has an extra. There's something extra in his brain. He's a charming. He's also a concert pianist. Okay, he has like 4 records. Okay, so he really got a really high initial endowment, as the economist would put it, in his brain. And Hamid Reza is an Iranian student of mine who will hopefully finish next year. Mohammed bin Qasmi is a dear friend who works in Morocco. And I'll stop there. And you didn't interrupt me, so I didn't get to breathe. Yes. I'm used to projecting my voice. I don't need a microphone, actually.
Okay. So, sir, NTL obviously has a lot of benefits, and towards the end you mentioned how you faced a problem with China, right? And which is why you had to cross-reference with WeChat data.
Yeah.
But on the whole, there seemed like a lot of more of pros to NTL? Like in some cases where luminosity wasn't available, you said that there were some other parameters as well, like fumes, biofumes or something like that. So sir, why isn't this taken up on a grander scale by governments? Because governments, like, they pour a lot of money into survey design and a lot of stuff,
I
right?
agree with you. I don't know why. So I did a presentation at the Ministry of Finance in Delhi. When was it? I think it was in May, something like that. And they're really interested. NITI is really interested. NITI Aayog should be doing this full time. They should have a whole group of people doing this. And the Ministry of Finance is really interested. I don't know. It's sort of bureaucratic inertia, right? That happens. And then there's some vested interest in terms of doing sample surveys.
Yeah, a lot of people will lose a lot of jobs if
Yeah.
NTL catches up.
But India's going to continue. You guys have the best survey data in the world,
Yes.
right? I mean, in my field, in development economics, sorry to say this, but it's Indian imperialism, okay? Because the number of papers based on, everyone knows Aurepale, okay? It's one of the villages in the old ICRISAT data. Everyone knows this village. Everyone knows Palampur, right? Bliss and Stern, right? So not a lot of people are not going to lose their jobs because there's this reputational effect. Indian microdata, basically development economics is Indian microdata. People understand sharecropping, credit constraints, etc., based on India, and quite often it has nothing to do with what's going on in Africa or Latin America, by the way. Okay, so no, India will continue producing microdata, and you produce the best microdata in the world. Certainly for ceteris paribus, for the income level, you certainly produce the British did a lot of bad things, but they left you with a great statistical sort of heritage, right?
So did the British leave us with it, or was it largely like
The British,
Maulana
to colonize someone, you need to know what's going on. So you have a good statistical setup to control people. That's one good thing they did. It's one. Right?
One.
Grant them that. I'm not British, okay, so I'm not talking about myself.
No, I get it.
Yeah, I mean, this should be used a lot more. It really should be used a lot more. It's free, and I'm sure that there's all sorts of things in terms of financial inclusion that could be done with this, right? If we want to look at the impact of financial inclusion on outcomes, do it at a very granular level. Try to look at, when people remember all the literature on the rollout of portable ultrasound machines in India, right? You remember that? And so where one saw all this stuff on sex-selective abortions, and that was diff, okay? That was basically the rollout. So it was a difference in differences, and one could follow the rollout of the mobile, the portable ultrasound machines. And then when people knew the gender of the baby, then unfortunately, there's gender discrimination. You could do the same thing with financial services, with financial inclusion, right? If you have stuff normally doesn't get rolled out all right away at the same time everywhere, right? There's always pipeline delays, right? So one could probably follow this stuff over time and simply use NTL as one of the outcomes. I'm not saying just do that, but does financial inclusion lead to more economic activity? Pick it up through NTL, right? You don't have to have a sample survey. You have the universe. You have every single pixel in the country, right? So it isn't as if you have to hope and pray that you have, an ICRISAT data set, or a national sample survey which corresponds to the place where you're rolling out your financial product. Where NTL, it's daily for every pixel in the country. There's no excuse not to use it. Let me put it that way. It sort of seems to be like trying to do stuff, with an arm tied behind your back by not using it. I'm trying to sell this. I have nothing to offer you, man. I don't make anything off NTL, right? So it's a freebie out there, right? It's a low-hanging fruit, and low-hanging fruits are made to be picked and eaten. Don't be shy. Come on, the IIT people gotta ask questions. The professionals should ask questions too.
So does NTL in and of itself help tackle the question of quasi
the NTL is just a measure of outcomes. Then the causality comes through your identification strategy, right? So there'll always be 5 identification strategies. RCT, you can do RDD, you can do diff-diff, you can do instrumental variables, or you can do an identification strategy, which isn't an identification strategy, do matching. Just assume away the problem, right? Run OLS or do matching. So your results, the causality, the causal interpretation of your results is only as good as your identification strategy. NTL is just simply, it isn't a new method, it's a new datum. It's just simply a piece of data for outcomes that people haven't exploited enough already. That's all. You can do bad work with NTL just as you can do good work with NTL. Right? So, I mean, the example I was giving you was RDD, where it was very clear, and then the stuff on Gaza, that was difference in differences. But you could do this with RCTs as well. Right? You could do it with RCTs as well. You look as if you have a question. No? Yes.
Not really questions. I'm not a mathematician, so more technical.
Neither am I.
But then the example that we took was for Gaza, where of course our correlation coefficient would have been very, very positive, looking at the pixels that you received. But was it not meant to be like that? Because that's a very, very obvious situation that actually took place, which would obviously have impact on the economical activity in that space. So according to me, that correlation is quite obvious to do. Then why do we really have to, we need an, NTL to give us that information?
It's because we don't have income or expenditure information at a disaggregated level.
Okay.
Okay, when you do a sample survey, I mean, in China, you can do something which is nationally representative with a sample survey with 20,000 households. Okay, but you can imagine in the size of a country like China or like India, that comes from just a very few little places where you actually have the survey data.
Okay.
Right?
That's true.
So if you want the universe, okay, the only time you get a universe in survey data is when you do a census. Okay, that's what a census does, right? It contacts every household in a country, right? That's what poverty mapping is about. So poverty mapping, the way it works is you combine, for those of you who don't know what it is, it's one of the most beautiful tools created in the past. It was the late Jenny Lanyau and her husband, who they're at the World Bank. She unfortunately died very young. So basically you take household survey data where you have incomes or expenditures, okay? But you only have it for 1,500 or 2,000 or 8,000 households in a country, depending upon the size of the household survey. And then you combine that with census data. But census data never gives you any information. I don't know any country where the census talks about household incomes or expenditures. Okay, it'll give you a few characteristics of the household. It might, in some countries, it tells you something about education. Sometimes it'll tell you something about, in some countries, I've looked at a lot of countries on this sort of stuff. In some countries, it'll tell you what is the roof made out of in the house, what are the walls, what is the flooring, but you don't have very many indicators. Okay, so what poverty mapping does is it estimates a model on the household survey data, on let's say the 2,000 observations, of income as a function of a bunch of variables. And the variables that it takes are the variables where there's an overlap between the information in the household survey and in the census. Okay, because there's going to be 5-6 variables which exist both in the census and in the household survey. Okay, so you estimate this model, so you have a decent, it can be as complicated as you want, a decent model of household expenditures or income as a function of a few variables, which also exist in the census, okay? So then you take the census data and you apply the coefficients that you've estimated in that model, and you extrapolate to every single household in the country, because it's census data. So you have information on those 4, 5, 6 variables for every household in the country. Okay. So you basically come up with an estimation. There's a standard error around it, okay? There's a margin of error, but you have a nice estimate of the expenditures of every household in the country, okay? But the thing is, you can only basically, the census data is like, in most countries, it's every 10 years, if you're lucky. Right? In some places, it's like Angola, they had a census like in 1960, and then they didn't have another one until 2009. I remember the statistics in Angola once telling me, I don't even know how many people are in my country, right? Because they hadn't had a census in 50 years, basically. So that's how, and then when you have the poverty mapping, so you have this noisy measure, noisy in the sense that it's estimated, so this synthetic measure of income or expenditures for every household in the country, then you can aggregate that up to whatever level you want. It could be the state, it could be a district, it could be a taluk, it could be a village, whatever, or you simply aggregate it up to pixels. Okay, you simply aggregate it up to pixels at the same resolution as your nighttime luminosity. And then you correlate nighttime luminosity at the same level of aggregation as what you've aggregated up, where you've aggregated up the poverty mapping, and voila. You are then able to say, well, if nighttime luminosity changes, you estimate a model, and then if nighttime luminosity changes by this amount, well, now I know by how much, on average, household income or expenditure is going to change. So it's a wonderful practical tool, you see, because you're not going to have household survey data for that many households, and you want to say something about everywhere. And with NTL combined with poverty mapping, you can say something about everywhere and every household in the country, with a margin of error, sure, okay, with a margin of error, right? You have to take that into account, but it's better than nothing.
And anomalies are going to exist, and especially in a country like India, like you said, the example that we spoke about in China, the bridge was illuminated in the night, and that was an anomaly, so we had to take another variable.
You can bring other stuff in as well, yes.
Yeah.
Every country is different from that standpoint.
And India is definitely far more dynamic and far more, every district is very, very different from, the existing one. So I think what we have to keep in mind is to look for these anomalies so that our errors are as minimized as possible, basically.
That's why you need to have people who actually know what's going on the ground, right?
Ground, yeah.
Okay, there's no panacea. Okay, this is not a panacea. It doesn't stop you from actually knowing what's going on the ground. Right? You always need people who know what's going on the ground. That's absolutely absolutely essential. But it just surprises me the governments don't use this more. Yeah.
Thank you.
You're welcome.
So, sir, are we saying that
is producing it, but it doesn't tell you. No, it doesn't tell you who is producing it.
so, sir, that margin of error you mentioned, does it account for?
No. That's another issue. That's a completely other issue. But you see, for example, in Gaza, what was I used to follow this day by day. So as the bombing was in northern Gaza, what you would see is slowly over a period of a couple of weeks, you saw the NTL went out in northern Gaza, and then they ended up in Rafah, near the Egyptian border. And so NTL actually increased in Rafah and you could follow the population movement. Okay, as the people got bombed out of northern Gaza, well, they moved to Rafah near the Egyptian border, and NTL went up there because people were moving. So no, it's not a substitute for census data. But remember, census data tells you nothing about incomes. You don't have any information about incomes or usually about health. Sometimes you do about education, but incomes and health, you have no information on that in census data.
So, sir, if NTL provides us with a starting point with regards to income and health, so, sir, let's again take the example of India, because that's where we are right now, where other than in very remote areas, electrification has been attained to a great extent. So, sir, how will the scale of development be measured in India with regard to changes in NTL?
But it shows up. Whether you're electrified or not, it shows up. The only place where it can become difficult is in megacities.
Exactly.
Okay, in megacities, you get, to a certain extent, you then get to problems of saturation. Okay, the nighttime luminosity can become completely saturated.
One pixel
Yeah,
is one
and
light.
yeah, but you can no longer see the variation. Okay, but apart from that, it's especially in rural areas or especially in second and third tier cities. That's where it's especially useful because no one's collecting data on these places, right? And you can. I mean, like when you look at Africa, for example, and you want to know, as you know, there's a huge HIV/AIDS epidemic in Africa over the past 30 years. Well, I mean, it correlates perfectly with NTL because it basically follows the truck routes, right? And then you correlate the truck routes, NTL, which you see. Okay, you can see all the few long distance roads, and that correlates perfectly with epidemiological data on HIV in the field. Okay, I've used this also for example, in Burkina Faso. Sometimes I just use it as a covariate. So, for example, in Burkina Faso, I was looking at with Daniele, with that again, Daniele Rinaldo, where we have a paper in infectious diseases of poverty where we're looking at the effect of schistosomiasis, okay, which is bilharzia. Okay, so it's actually, it exists in India, but it's not recognized as a major public health problem, but actually it is. But it's sort of the most severe infectious disease in India that you've never heard about, okay, schistosomiasis. It's basically propagated by little snails, and it gets into your urinary tract, and then you take the medicine, but then the minute you go back into the water, it comes back. And so what we were looking at is we were trying to look at the impact of schistosomiasis on agricultural productivity. Okay, so we had household survey data in a whole bunch of villages for 50,000 households over a 20-year period. But we could have done this with NTL as well. Actually, we did it with NTL as well. So we had epidemiological maps on the severity of infection. So this is stuff that medical doctors had collected over years in Burkina Faso at a very low level of resolution. So we knew how many, and we even had an IV because we had the schistosomes, which is the thing which goes into your urinary tract, and then that is the vector are these little snails, and we also actually had an IV, which was the presence of the snails, because they don't have the snails don't hurt you per se, but they're associated with the transmission of the schistosome. And so we did that with household survey data, but we could have done it with NTL as well in rural areas in Burkina Faso. So this was for the effect of a health problem on economic activity, and we found that schistosomiasis in Burkina basically was cutting 1% of GDP, especially in places where there were large dams. So so this is another example of sort of why it's important for policy, right? Because basically you build a large dam, you transmit these snails. So the marginal return in Burkina Faso, at least, to investment in irrigation was much lower than they thought it was, because you're making a whole bunch of people sick. So what I was presenting at Kautilya a couple of days ago, at the Kautilya Economic Conclave, my little intervention, they asked me to talk about stuff I've done on malaria and tuberculosis, okay? And that's also an area where one could do something really interesting. So you know that India, malaria and tuberculosis, India represents between 5 and 7% of the global burden of those two diseases, okay? So this is a big deal. The big intervention which is coming in tuberculosis is a vaccine, which is going to be introduced in 2028 in a lot of countries. I think in India it's in 2034. And malaria also has huge impact. I've worked a lot on the impact of malaria. I have malaria. I caught it in Tanzania when I was a kid, and malaria attacks is not something particularly pleasant. I haven't had one in like 25 years now, but I used to get malaria attacks once in a while. And again, that's another thing where most of the evidence, so I have a paper in the American Journal of Tropical Medicine, which is cross-country growth regressions. I hate cross-country growth regressions, where, growth rate of GDP or level of GDP, stupid GMM estimation, on malaria prevalence, okay? And then we have some nice IV results anyway. I'll spare you the details. What I've never done, but which actually I do, but it's a low-hanging fruit. Some master's student got to do this as a thesis, is there's the people at Oxford who are now in Perth. They were bought by the University of Perth. They have this wonderful thing called the Malaria Project. It's a map, it's an interactive map, pixel by pixel, of malaria, the presence of malaria everywhere in the world, okay, at the pixel level. Africa, India, you name it, okay? Correlate that with nighttime luminosity, right? Put nighttime luminosity on the left-hand side. You've got panel data, you could do, there's like, the data points of malaria, prevalence of malaria is huge. You want to get an original paper that no one's written yet, you get the impact of presence of malaria on nighttime luminosity, and then you turn that into income by looking at the exchange rate between nighttime luminosity, and which is nonlinear, by the way. When I say 80 r squared of 0.8, there's actually a few nonlinearities. It's monotonic, but you could improve on that with a nonlinear model. But again, that's an easy paper to write. As far as I know, no one's writing it. No one's written it. So do it for a thesis. Do it for a master's thesis. It's an easy one.
I have one question. So in our work, one potential application of nighttime luminosity could be in estimating credit absorption capacity. And now, most of the work that we've seen today seem to use nighttime luminosity in a sort of post hoc sense. So it's giving indications about what is happening or what has already happened. But when you're thinking about credit absorption capacity, you're thinking about latent economic activity. So not economic activity that is already unfolding, but economic activity which could potentially unfold if you were to bring credit into those areas. So what I'm curious about are your thoughts about how we could use something like nighttime luminosity in that context as a Proctor Hawk measurement tool.
Could it be sort of a leading indicator? One would have to do some sort of kind of modeling on seeing, right? There'd be some kind, you'd use it as a leading indicator for the capacity to absorb financing, right? Something like that. Lag it, see what the structural relationship, if any, is, and then project it, right, in other places. I don't know. That seems to me. It's straightforward. It might be stupid, but I just lag it. Yeah, use it as a leading indicator. Yeah, I don't know.
It's been a while.
We should try it. We should try it, right? We should try it.
One basic question, when you spoke about the malaria example, you said you can correlate the malaria prevalence with the nighttime luminosity, and then you also said then by doing that you will be able to understand the impact of malaria prevalence on economic activity. How does the impact part happen or unfold?
You have to establish the exchange rate between nighttime luminosity and income. Okay, but there you have all sorts of information on income at the global level, right? So you could do a stupid cross-country growth regression, panel cross-country growth regression, where you look at average nighttime luminosity by country, by decade, right? And you compare that to GDP per capita per country per decade. That's sort of not pretty, but you could do it, or you could go to microdata, like the World Bank harmonized data sets for a whole bunch of countries in the world, and you could try to get your answer will probably be pretty close. The link between nighttime and I mentioned in one of the slides. There's this paper. I think it never got published. It's this paper by two Chinese colleagues at the World Bank. The Hu and Yao's paper, not at the bank, at the IMF. That's a really nice paper. Which gives you all the caveats. So we were talking about the caveats, the weaknesses. It's not a panacea, but that gives you the sort of the nonlinearities in the relationship between NTL and growth.
And from which time period is NTL data available?
2012.
Okay.
Consistent black marble data from 2012. If you want to go back before 2012, there's splicing, and I wouldn't. Most the people who actually know this stuff, my geographer friends, they wouldn't touch this with a 10-foot pole. They say it's not clean.
But maybe I want to check.
Yes, of course.
But I interpreted Misha's question to ask, and correct me if I'm wrong, Misha, that what these regressions don't do is they don't uncover the precise causal mechanism. That's what you were that's what you were getting at. Because the causal mechanism is the holy grail of econometrics. So I think much of the work but I think you could tell a reasonably.
This is reduced form.
Yes, and
this would be a reduced form.
So you're not estimating the structural equation. You're estimating the reduced form equation. So the structural equation, I suppose, is impossible to uncover in these kinds of contexts.
No, if you have good observational micro data, you could. It's not the randomistas who are going to do it, right? The randomistas, the people who do RCTs, all they care about is they estimate a reduced form, right? It's intent to treat. That's all they never estimate the structural equation, despite the fact that they have the perfect IV with the randomization. But they never try to go structural or to look at heterogeneous treatment effects. No, exactly. if I can suggest one, I'm trying to remember his name now. I'll look it up. I'll send it to you. There are smart randomistas. There's this one paper in the AER, actually goes back to 2012, and it's what's his name? And actually, basically, they set up randomization as a principal agent model. Okay, so basically it basically uses an incentive mechanism. So people, okay, so it's like a de Groot mechanism for those of you who've ever done public finance, and so basically you randomize in terms of, so people have a willingness to pay to be treated. Okay, so what you want to know is different people benefit differently from a treatment, right? Okay, what the randomistas in some sense sort of always sweep under the carpet is all they look at is the average treatment effect, right? So the example I always used to give to my students when I was teaching impact evaluation, suppose you have a treatment, half the population has a treatment effect of -1, half the population has a treatment effect of +1. The average treatment effect is 0. It corresponds to nobody. Okay? So you have to be able to find ways to elicit different marginal treatment effects for different people. Different people in this room respond differently to the same aspirin, right? Some people respond differently to aspirin, some people respond differently to Tylenol, whatever, right? We're all different in terms of how treatment affects us. And so there are some smart randomizers out there who set the things up. So basically, you have these incentive-compatible mechanisms, and you reveal what you believe you're going to gain from the treatment. But most of the JPAL type stuff just doesn't do this. Well, actually, none of the JPAL stuff does this. I have a student who did it, an American student who did it in Ivory Coast, Northern Ivory Coast, introduction of landrace rice varieties. So these are old varieties which have almost disappeared, and so they're trying to reintroduce this old genetic material. And so he set up a smart randomization, where he got the willingness to pay for these new old rice varieties, and that way he was able to basically estimate the whole distribution of the treatment effects. But you see, just trying to explain it to you, it sounds complicated because it is, but it's smart. And there you're really getting to causality. But the point is, how anyone can believe that an average treatment effect is of any interest to anyone, I'm sorry, I just don't buy it. Right? And the other thing that the randomistas never do is people change their treatment status. Okay, so I mean, when I was much younger, I used to for 3 years I lived in Brazil. I participated in these. I was in a public health center, and they were doing vitamin supplementation programs. Okay, and so we were in the poor black. They call them invasões. You call them favelas, but favelas in Rio de Janeiro. In northeastern Brazil, they're not called favelas. Anyway, that's a carioca word. So the pill, the vitamin supplement that they were taking, was red and black. Okay, I know that that's the color of a political party here, but that was not the point. The point was that red and black in African religion is the color of Eshu. Eshu is the trickster. Okay, so like the devil, basically. So when they were doing, with the people who were treated with the program, if they go into a black household, they sort of say, yeah, I'm taking it, and then they just like throw it under the table, right? In white household, they take it, right? Because they weren't adepts of Afro-Brazilian religion. And no one had realized this, and we're starting to get these results coming in, and they made no sense. If someone in the team had talked to any anthropologist, they would have realized that this was complete crap what was being doing. And so all we did is we changed the color so that it was white, nice neutral white, then treatment worked. But you see, they were counted, these people who got the pill, they were counted as having received the treatment. They were treated people, but they weren't actually treated. Right? People will find ways to get rid of something that they don't want, and the other people, suppose that they really wanted the treatment, they'll find a way to pay someone to get the pill. So that they come out as being untreated, they'll find a way to get it. And humans are humans. You can't assume, you can't, why would you want to construct something which gets rid of human behavior? That's what the causality has to do with human behavior. Anyway, it's a losing battle to fight to fight these people, but it's a battle worth waging.
Okay, I think we are.
Yeah, we're really out of time. Yeah, people have been extremely patient. Thank you.
Thank you, Jean-Louis, for that extremely interesting talk. And certainly we are going to pick your brains in the coming months because we want to do some work with Nightlight's data as well. But thank you also for to the audience for showing up and asking interesting questions. And I just have one thing to give you, and this is just as a token of our appreciation, Jean-Louis. So, yes. It's a book, I believe. Yes, yes, of course.
Books I never had enough.
Okay, so we are going to officially close the streaming as well. Thank you, everybody.